Thank you for coming back at pub time after break. I appreciate it. I'm Stuart McMurray. I'm a red teamer over at IronNet. Really, for us, that means I'm a general Unix nerd, Swiss Army knife type. His Twitter handle, Twitter QR code, makes it a bit easier. And before I talk about Pcap, I'd like to point out I'm not at all affiliated with Nmap, Wireshark, tcpdump group, anybody else. I very much enjoy the projects they have, but I'm not a developer or contributor or anything of that sort. Standard disclaimer that this is anything I say is not necessarily the views of my company. Also, please don't sue me or anybody if you do things that you oughtn't. And if you do, please don't tell them you know me. Right, so the genesis of this talk was a cyber defense competition that some college kids did, where they have the college kids defending the network and local professionals undefending the network. And we had a team that found that any network comms were bad. It's a range, right? A test range or a competition range. So pretty much any TCP comms that were not their services they were meant to keep up were bad. So it's like, okay, fine, I'll use UDP. And they figured out that, hey, anything UDP at all is bad. And I was like, okay, fine, I'll use a raw socket. And I figured out anything a raw socket is bad because it still shows up in netstat. And they just netstat in a loop, right? So that got me into Pcap. And it turns out you can do a lot of cool stuff with Pcap. So it's libpcap. It's just a library that wraps, on Linux, it wraps packet sockets. It has a whole bunch of different underlying technologies on 140-ish different targets you can build it for. It's a C library. Quick question, how many know C? Oh, wow. Okay, awesome. We'll see some C code. For those who don't, there's FFI for a lot of languages, so a lot of wrappers. Python has a pretty good one, Scapy. It's few URLs there. tcpdump.org. tcpdump uses Pcap heavily and writes libpcap. Their documentation is excellent. Nmap, of course, we all know and love Nmap, but they write the Windows driver, npcap. It's sort of the successor to WinPcap. There's a Go library for the Go programmers that is quite good. It will require CGO, so if you don't like CGO, please write in C. And finally, Scapy is very helpful for doing anything Pcap related. It's a Python shell plus. It's a Python shell, but a lot of syntax sugar for anything injection. So this is a generalized, very notional layout of what Pcap is in relation to a notional Unix box. Christian, awesome. So you are here. We have a NIC, we have a connection to the network, and we have some application using libpcap that essentially does a read and write, or send and receive on layer 2 frames. So it'll notionally, and this is of course not how it works under the hood, but it'll send frames from your application to the NIC and out to the network, and then you get frames from the network, you get it into the NIC, and you receive it into your application, filtered a bit. Talk about later. Notice the firewall is over here. So one of the nifty things is even if somebody firewalls on the box, okay, doesn't do us any good. So this is not on Windows. Windows works the other way around. We'll see it in a bit later. But for a general, you're here, right here, talking more or less ish directly to the NIC. That's cool and kind of painful because now we have to roll our own Ethernet frames. So why would you do this? It's not exactly the easiest thing to do. Well, from a CPU perspective, HTTP it's a well-known thing. And if you can use HTTP and that works for you, if you can just throw up Cobalt Strike and you got out, you're awesome, that's good. That's not always how it works anymore. And HTTP is well known, we all know it. Defenders also know it, and there's lots and lots and lots of tooling for HTTPs. Okay, so maybe we use HTTPS. It's just another letter for most of us, right? And there's getting to be more and more tooling around HTTPS. Okay, so we'll domain front. Domain fronting has the problem that you're relying on some third party to help you, and they typically don't like helping you. Asked an Amazon dude, hey, music.amazon.com, CloudFront. He's like, don't do that. So I stopped. So maybe domain fronting is not necessarily the answer. And if it is, it's awesome. Use it. So we'll use DNS tunneling. DNS tunneling is not fast, and it's not necessarily trivial to get to work just right and not get caught. And it's actually not, in a lot of cases, not hard to catch. Working with a bunch of dudes, and they're like, hey, we need some tunneling. We're testing a thing. Write us a DNS thing. I was like, use iodine. They're like, we just got our DNS server blacklisted because it was running iodine. So DNS tunneling maybe doesn't work for you. So and then just okay, it's fine. I'll just make a TCP socket out. I'll use some high port. Nobody will even notice. Well, that'll still leave a little bit of a trail pointing to the box you victimized. One of the nice things about Pcap is we can have source addresses, source MAC address, source IP address, source whatever layer 2 address that just don't point to anything. And at that point, you have to start you have to go to switches and be like, hey, switch. Okay, what port is this address on, please? Hey, switch. What port is broadcast coming from, please? That doesn't get very easy. Okay, so that's like the C2 side, the fun, we got a shell side. What about sniffing? It's kind of like, we all run tcpdump, right? Well, turns out there's a lot of cool things that you find on networks. It's on a bank's network at one point. And I was like, well, I have a box. What do I do? And so I just I was watching traffic. Turns out they had LDAP running. All right. Turns out LDAP was passing Unix hashes. All right. Not great hashes, but all right, sure. And then SSH was using it. So anytime anybody tried to SSH into the box reached back to the LDAP server, grabbed the hash. All in plain text. It's okay, so now I have every Unix user's hash. Hey, you should have more than 8 characters in your Unix password, by the way. So as far as sniffing goes, it's really cool to put tcpdump on a box. I got lucky it was on there. When you put tcpdump on a box, usually you have to bring libpcap with you, and that, maybe it's not what you want to do. Maybe you don't want tcpdump syntax in a process listing. So rolling your own is actually a really good way to go. We'll see that in one of the demos we'll have. So you can do, things that most tools do, but just an ad hoc, bespoke way, and it'll work a little better sometimes. If can tools work, use them. It's quite a bit easier. So, and also you can have comms without normal network sockets. I don't want to spoil the demo later, but there's if you're getting frames straight from the NIC, there's no real need to actually open a socket. You'll have a packet socket on Linux or a BPF device or whatever, but, you have data into user land from the network without actually opening a socket. So I alluded to frames from non-existent sources. I don't have a demo for that, but it works. And then non-existent protocols. So you take, say, TCP, you switch the IP proto from IP proto TCP to some random number 100 or something, and it'll route. All right. So, the good news is about half the audience speaks C. So we'll go through the C API very quickly, briefly, just to a little, whirlwind tour of how to libpcap. Each of them will present what the function call is, and a brief demo, text, highlighted with the important bit highlighted. Of note, there's a lot of error handling. I myself am guilty of just finding, hey, slides that do what I want, copy paste. That doesn't usually mean copy paste checking errors. So, the error checking is nice and built in. Before we do that, it's not necessarily obvious the first time you do this what order to do things in. How many of you read Beej's Guide to Network Sockets? Okay. So for everybody else, if you don't write network sockets, Beej has this really great guide to network sockets. Yes, and you socket bind, accept, so on and so forth, listen, accept. So tcpdump man pages are a great place to start for Pcap. And then seeing it in practice, OpenBSD's source for a lot of things, especially OpenBSD's implementation of tcpdump, is really very clean and easy to read code. Failing all that, just search GitHub. Search for whatever function somebody, hey, I did use Pcap Open Live. So, speaking of Pcap Open Live, first we have to attach it to a device. We take, your NIC on the Unix side, it's something like ETH0, and say, I would like to capture on it, please. I would like frames from this device into my program. You give it a few other parameters. I am going to be pressed for time. I'm not going to go through them each one, but you give them a few other parameters, and it will return you a handle. It's sort of an opaque pointer, as C often does. This is what it looks like in real life. So we'll start capturing EM0. Set a fairly large capture buffer. If it's too small, you run the risk of missing chunks of packet. Or that's maybe okay. Maybe you do actually only really care about the header. Of note, you need to pass in an error buffer if you want to see what the error that you get is. Then you have an option. You can either Pcap Open Live, which allows you to set some parameters. You can Pcap Create, which is more or less the same. It's sort of the modern way of doing it. And you give it your source device EM0 in the last example error buffer. And then you can set some options. You can say, hey, I want this timeout when buffering packets, or I want this timestamp type, or what have you. And then you activate it. Pcap Open Live does that all in one go. That's about what it looks like. You call the 3, check for errors, and then just use P sort of as a read and write. So before that, typically you compile a BPF filter, and this is like you see in tcpdump. I want TCP port 80, or I want TCP port 443 and the push header or the push flag set and the send flag not set, or something along those lines. You can get very granular. BPF is actually a complete language. It doesn't loop, but it's like a forward language that runs in a little VM, so you can do some interesting things with it. Anyways, you got to compile it to VM bytecode. That's how you do it. And then you have to set it on your Pcap handle. When you're done, free the memory is allocated. So that's what it looks like. So in this case, I'm intending to dump on TCP port 80. I will compile that to a struct BPF program, and I'll pass that and set it on the filter, and I'll free it. Before we actually do anything interesting, you're not, especially in Linux, you're not guaranteed that your layer 2 header is going to be what you expect it to be. Even if it's an Ethernet device you're dumping on, it might not actually be an Ethernet header. It might not be the 12 bytes-ish. Forget the exact number of an Ethernet header. So you have to ask, say, hey, Pcap, how big is this header? And it will say not how big the header is. It'll say, this is the data link type. And then you have this big old switch statement. It's like, if it's Ethernet, it's this. If it's raw, it's this. If it's whatever else, it's whatever else. This actually comes in handy if you don't really know what the device is. Linux device names are not necessarily accurate, especially when you get into the Kubernetes Docker side of things. So it's kind of important to know how far to go, if you care, if you're actually going to start parsing packets. This is what it looks like. So we have some magic initialization of P, which we'll use in the future slides as well. Grab the data link type, and then you'll have some sort of switch. Well, I had it somewhere in the code. Anyways, you'll have some sort of switch. Note 2 functions, pcap data link, valid name, and description, which I totally skipped over in the last slide. Give a nice human-readable name for your type and a brief description. So if we want to receive packets, there are equivalents to the receive or read system calls. It's often easier if you're just going to keep doing it to loop it, and it contains a looping function built in. So you pass in that opaque Pcap handle. You pass in a callback function, and you also get this nice little user pointer. You can put in there whatever you'd like. It's an unsigned character pointer, but you can cast it to anything. It's just a pointer. So assuming you're on a system where you can cast pointers to anything, which is most of them nowadays. Your handler looks like this. There's that same user pointer. It's passed in straight. This is all single-threaded, by the way, so that is mutable. So notice it's not a const. It's just a pointer. Is that little thingy showing up? It is. Well, that's cool. That's not what I wanted. Anyways, you get a Pcap packet header. Apologies for the quirk there. You get a Pcap packet header. It'll tell you the amount of data you got off the wire and the amount of data the packet originally was. If your capture buffer is too small, because maybe you only care about the headers or something, then you'll know how big the packet was originally. And finally, you get the buffer for the packet. That's what it looks like. You loop it, you give it your callback, and it goes. Error handling, you can break out of the loop with pcap break loop, I believe, in which case you'll get a -2 as a return value. It's about what a handler looks like. Obviously, in real life, they're a bit more interesting than this. Taking this, the user unsigned character, casting it to an integer, and we'll just take it as a contrived example to count the packets. But notice we get the length of the packet on the wire, the length of the packet we've captured, and you can index into it just as any other pointer, like any other unsigned character, i.e. byte pointer. Pcap inject is the send or write side of this. Just like any other write, you give it, instead of a file descriptor, a pointer. But other than that, you give it a buffer and how many bytes, and it just goes, puts it on the wire, which means you have to actually get your layer 2 right. If you mess up your layer 2, it's not going to go anywhere. So unlike a raw socket, you actually have to take care of the entire stack. You don't need an Ethernet trailer, an Ethernet checksum, though. The device driver will handle that. So what it looks like, it looks pretty much like any other write. We've initialized our Pcap. We've found some way to generate a packet, and we've stuck it on the wire. You can get partial sends, especially in Go, I know, but I think C as well. In TCP, you just normally get partial sends. UDP, it's like, okay, did something wrong. Pcap, it's the same as any other thing that's stateless or connectionless. It's like, oops, goofed. A few other handy things. net.in.h is a header file that you include just about every Pcap program. It has a whole bunch of constants in there that are defined. There's a handful of functions, pcap lookup dev, final devs, and close, that will find a device for you. On the Unix side, it's easy. It's a short name. It's bridge 0 or tap 0 or eth1 or whatever. On the Windows side, it gets very complicated because they like to use UUIDs for everything, and device names are no different. So it's sometimes easier just to say, hey, user, here's a list of devices. Please give me a menu list. Give me a number or something. Those will handle that. As far as calculating checksums, I got sick of doing it by hand, so I wrote a library to do it. So feel free to use it. It's nice and ISC license or BSD license, every which permissively licensed. It has a single function in it, packet checksum calculate, and it calculates and inserts your checksums. So roll your packet at that, packet checksum calculate, and then send, or pcap inject. It's worth mentioning Scapy again. It's very fast to write in C, or very fast to run C, not so fast to write in C. And it tends to work forever once you get it right. But if you really just need to send a packet, Scapy is generally the way to go. There's a few handy structs that mostly provide headers here. So when you receive packets on the Pcap loop side of things, it's painful to calculate offsets by hand if you're doing one or two, whatever. But it's often easier just to point a struct ether header at the beginning of your packet, figure out how big that goes, point a struct IP at the next layer, and so on and so forth. Makes writing quite a bit simpler. For these, you'll often need net.net in.h included. Excuse me. So that's cool. C is fun. How do we actually run it? Compiling is almost like compiling anything else. This is just a wrapper around packet sockets and setting a BPF filter. So it's not that much different, except you have to link in libpcap. Libpcap is not necessarily always on target, so you might need to bring it with you, which works. So statically building it in solves a lot of problems. You can get the latest source there. I find myself typically, I just bring down the source, build it, works. So you can, on Debian boxes, of course, install libpcap devel or something like that, libpcap dev or whatever, which works. You're not necessarily guaranteed that libpcap is the same as the libpcap on target. So that's why I typically statically link it in. Things I found interesting or useful for writing PCAP programs, macros for config. We'll see in a bit, we're going to inject programs straight into systemd. So you don't really have the option to give it a config file. There was a report came out couple weeks ago about a group that they took their binary, they added a config file to the end, encrypted it, and hey, just read the binary, it'll be there. That's cool until somebody decodes your config file and writes a blog post about it. Also, I find it's quite handy to, instead of putting things in main, if it's just a single-use program and you're always going to run it that way, cool. But instead of putting things in main, making it a constructor function, which will run as a standalone binary or if it's injected. I was talking to one of the fellows who was talking about OS query yesterday and was like, all right, TLDR, don't run programs. So constructor functions as threads that you shove into things is probably a good thing to start doing. That's about what it would look like compiling. So in this case, you can assume that pcap hello world is going to ask what device, or going to need to know what device to capture on, so eth0, or at least what device to attach to. And for this case, we'll just link in pcap as you link in any other normal library. Those are the compiler flags I always use. They work pretty good. Everybody has their own. Other than that, you just give it the source and go. So then how to run it. As a standalone binary, it's like any other standalone binary, with the exception that you either need root on most Unix-like systems, capnet raw if you're running on Linux. On Windows, you don't necessarily need admin. If you install the pcap driver and service right, you don't actually need capnet raw. Now I would hazard to guess most of the time if you find pcap installed, it's because somebody's running Wireshark to debug something or forensic something or what have you. So it probably won't need admin. It's not a bad thing to drop privileges because at this point you can do all sorts of strange things and buffer overflows happen and so on. And I found I drop tcpdump on a target or drop nmap or whatever and just say, hey, is pcap there? LDD will tell you. An injectable library, it's no different than any other shared object you build, except that the process you inject into needs to have some access to pcap's underlying mechanism. So this is not, you'd think, oh yeah, any root process works. It's not actually how it works, it turns out. I have yet to figure out why. So feel free to tell me. But systemd works. It's not the stablest thing ever. syslog tends to work. NTPD tends to work. So yeah, containers cause trouble, as they often do. But the cool thing is then you attach it to a bridge device and you're like, hey, I own all the boxes. So pcred create and then a double fork can often solve your problem. So you inject into a process, you fork. You inject into a process, you spawn a thread, you fork. Now you have another process that has no binary on disk. If you're going the SO preload route to inject, and it's not necessarily a pcap thing, but there's no idempotency with pcap. If you have everything, and speaking from experience, you injected everything and everything's listening for a trigger packet or something and it gets it, then you have 1,000 shells calling you back. It's not always what you want. LD preload is a good way to take care of that. If you can sneak that into an init file or, I think the group I was reading about put it in Etsy profile. All right, so first of the demos, this will be a little program. It'll just send hello world as the layer 3 payload to the broadcast address. So we'll have Ethernet hello world. Like we saw a couple slides back, we'll select the interface we inject on via the preprocessor macro. So ddevice. It's worth noting, I did not point it out, the / quotes are important because otherwise it assumes eth0 goes straight into the source and not as a string. And And then we'll write this so that it happens in a constructor, not in main. Saw somebody taking pictures. I'll put these slides on Twitter right after the talk. So yeah, we'll run this in the constructor, not in main, just for the sake of injection and makes for a good demo. There's source and ASCII cast. All these demos are recorded as ASCII casts, by the way. So if you look me up using the same Twitter handle on AskInema, they're all there, nice and copy pastable. So that is not the demo. That is the demo. Wow. Gods of apologize. This is going to be every one of them, I think. So my apologies. There we go. So on the demo box, we're going to grab Pcap source code. We're going to compile it just like you compile almost anything. If you think back like the old Slackware days of everything, configure, make, install, minus the make install, because we don't really need to install the system-wide, also not root. But we need the compiled libraries, that's it. Don't need to be anywhere special. This happens. Pcap is a well-used, tested bit of software. It's not likely that the compiler warnings are a bad thing necessarily. So we'll grab the source. Let's have a look at the source real quick. There is the layer 3 payload here. Notice net.n.h, and this is how you include Pcap. Older versions of Pcap, if you're on a really ancient box, it might be pcap/pcap.h. There we go. So here is the actual, not main, but the function that'll run before main. It's real simple. Grab make a buffer, null it out. We'll point an ether header at it. Copy in the source dest addresses and the ether types. We'll use the chaos ether type because it's a demo and it makes it really easy to find on the wire. It's also kind of neat if you're showing like, hey, look, I'm on your box and I could, in theory, inject whatever I want into the network, but it's something safe that I know nothing's going to pick up. So use whatever ether type you'd like. Unless you have old Lisp machines on your network, chaos is probably pretty safe. So copy the buffer in, and then it's almost just like opening a socket. Open the device, inject the frame, clean up, and we're done. Notice main just returns. There you go. So this is how we would compile it as a binary. It's pretty much the same. We set the include path because we're going to need to figure out where pcap.h is. So set the include path so we can find it. And then we'll compile in pcap statically. The rest of the library will be dynamically linked. Just libpcap will be in there statically. There we go. And we see it. It's looks like any other binary if you're doing super deep forensics. If you're at the point where somebody is looking at your malware and they're like looking at linked libraries, you probably should not be on that box anymore. But there we go. It's also kind of big. That happens. It's, static dynamic linking. Then we'll compile it as a shared object as well, just like you compile any other shared object. Another nifty way to compile in one thing statically is say, hey, linker, staticize this one thing and not the rest. And notice we have to point it at where the Pcap archives are. So looks pretty much the same, except this is a shared object file. Also, by default, debug info not stripped. That might not be a great thing if you suspect somebody's going to find your malware on target. So we'll just tcpdump real quick, and we'll look for anything not IP. Chaos is not IP. There might be ARP frames. It's okay. And we'll print out the hex and ASCII. I'm backgrounding it so we'll have like combined output. There we go. We'll run it just like we run anything else. And there we go. So we have our nice frame. It has an Ethernet header. And printing starts at layer 3, by the way. And it prints a hello world. And that's as easy as injecting is. You can actually do a lot of cool things with injecting, it turns out. So this is this typical DL open, shove it into a process. Notice we'll use PID1, which is systemd. Be careful with it. It's maybe not something you want to do just like, hey, I found a box. But it makes for like hey, yeah, you can't do this. And you're like, oh, watch this. There we go. We injected it. We got our normal void pointer. So DL open returned us a pointer as opposed to null, which means it worked. Yep, it did in fact inject. Again, if somebody's like going this far that they're looking in a init for your malware, you shouldn't be on that box probably. Cool. Also notice we have our hello world. It did in fact work in jumbled output. And we'll close it. There we go. That will segfault systemd if the library is still in use. So it works for injection, not so much for sniffing. So don't close sniffed anything. There we go. That was the demo. All right, so that's nice theory. So I have four little demos of what you can actually do with it. Most of these were written based on things I've done, but the source code wasn't public, so they're either re-implementations of or just proof of concept of things, other things that are internal. So first thing, we could just sniff the wire. How many of us have heard no, we don't encrypt inside. That's resource consumption and hard. Nobody can get in anyways. It's like common thing. Yep. There's like a million hands that are like this high. So I was working at this place. And they were like, yeah, so we're good inside. And then they use FTP to get from them to clients. It was a bank, by the way. So you see some FTP. If you're on an endpoint, it goes without saying you only get endpoint comms. You can get a lot of endpoint comms. So talking about the LDAP creds there. And if you're on a router, you can get anything traversing a router. If you're in an environment where they're using, say, the FreeBSD firewall, the name of which just escaped me. pfSense, thank you. Half the crowd. If you're using pfSense, compiles great on pfSense, works pretty good. And pfSense, everything runs as root, by the way. So, and the GUI reflects config files, not reality. So, works pretty good. Also, routers in the DevOps modern kube Docker world are usually Linux switch devices or bridge devices or something along those lines. So, your router is just nice and TCP dumpable. It's not a bad idea to filter narrowly. So if you add this to anything you're looking at TCP and you're actually looking at the internals of the TCP, little BPF filter bit that will keep you from having to deal with headers, basically, or keep you from having to deal with sins, fins, resets, so on and so forth. Means less time spent in userland, fewer copies from kernel to userland, and so on. There's a few tools that do this already. tcpdump, we used it a few seconds ago. It works pretty good. The output is not that great and easily parsable. I've done it. The first iteration of the LDAP hash thing was just tcpdump in Perl. It worked really good. dsniff is old, venerable, and works. There's a whole suite of tools that mostly are still relevant. And they have a lot of interesting Pcap stuff built in. And of course, Wireshark or tshark. Tshark gives you a nice configurable output. Wireshark is, of course, easy to read. So demo, little thing called Telnet Watcher. I wrote this originally to watch a Telnet honeypot many years ago. It just takes whatever payload, TCP UDP payload, and prints it to standard out. I was watching people Telnet in live. It was interesting. I've learned the hard way not to put things on GitHub and expect them to not be used in ways I don't expect. So all of these have something that makes them not just copy pastable by people you wouldn't want to use your code. This one's written for OpenBSD. OpenBSD is quite nice for development. There's not a lot of OpenBSD targets out there, so probably is okay there. Source code's pretty simple. Feel free to use it, modify it as you'd like. It's pretty much the same as this TCP dump line here. So you have a contrived scenario, which is from real life. So you've landed on a host involved in FTPing off some batched financial transactions, and you've got root. So yes, actually happened. This is about what this looks like. So we'll have some transaction transfer box running on FTPD, a bank it's sending, that we'll use for FTP comms to send transactions to, and we'll have somebody who SSHs into it, presumably to admin it, or maybe to SCP into it. And then we have us, the lead hacksaws, doing our thing. Pardon me. That did not switch. There we go. All right. Now, did I remember to set the lang? No, I didn't. So we'll just go like this. Would not be a demo if I didn't do something wrong. All right, so this is Telnet Watcher. So we're on his root, and hopefully you're not actually running getting help on target, but that's about what that looks like. So we'll ask it to capture on port 21 on VIO 0, and we'll ask it to print out unprintable bytes as hex. When I was TCP dumping, or when I was, actually watching Telnet has a lot of protocol stuff that doesn't get printed. So it was kind of interesting. Also, I found out that new lines and CRLFs don't always translate from system to system very well. So we're dumping, and looky there, we have Banker Joe logging in, and we got his creds. So that was, unfortunately, a pretty realistic thing that in several seconds now we have creds that, maybe we can reuse, who knows? And we see him batching off a file, so now we say, hey, by the way, bankers, I also have your data. I learned the hard way not to say I got root. I was talking to an HR guy, and I was like, hey, dude, I got root on your system. He's like, okay. I was like, so I can see all your files. He was like, okay. I was like, so I can read and write stuff. He's like, yeah, it's IT's problem. I was like, hey, look, payroll database. I found my salary. I could add a 0. He's like, oh my God. So, oh my God, we got transfers and we could change them in flight. Cool. So, was talking to it was a Unix admin, actually. It was an Amazon guy, I believe. And he found himself on a target, or on a box he was adminning. He's not a red guy. And he only had, true story, the OpenBSD installer. And he needed to get, it was like the one thing that would boot this. And he needed to get files off. OpenBSD installer is like a really small memory footprint. So like if you have memory that's all messed up, it works. And we're like, how do we do this? And we came up with the idea we would use the user agent field. OpenBSD FTP does HTTP. We'd use the user agent field, which works. It gets logged. So in this case, we'll notionally say on this box we have, SSH, say we have access to this and we want to exfil the key. We'll just use the password field. It's not likely to be logged anywhere. It's a reasonable expectation that this box can be doing a lot of FTP. Maybe not this box. Hopefully nobody's looking too hard. And something along these lines, we'll get an SSH key. Or you just tell it, watch to grab it. So that is the command we'll run on the SSH box, the internal box. So we'll dump on VIO0. We only really care about the user and pass, specifically the password. Anonymous is there's my little, that's cool. Anonymous is anonymous there. Sometimes typos get past tier 1. So there we go. Cool. So lurks, got our pass. Cool. So we'll basically reverse the Perl we used, reverse the sed. Perl is an awesome tool to put on target when you need something that you can't just like write a utility. Because you can't read that and I can't read that and I wrote that. And certainly the dude triaging this isn't going to read that. And there we go. We get our private key. It's actually a lot slower than this in real life. Eskinema has this nice thing where it'll like compress pauses. Like you watch a cooking show and it's like, and I put this in the oven and look, it's done already. Eskinema does that for us. So there's my cat sniffing the wire, by the way. All right, so next thing. So that was cool. So we've watched the wire. We've got comms. We sort of injected in a little like how to compile a demo. Let's actually make some comms. Pardon me. Let's actually make some comms without a socket. So there is technically a packet socket on Linux. There's a BPF device on most of the BSDs. Everything has some underlying mechanism. They don't usually show up in netstat peanut. This is what the university that I was red teaming against did. They just put this in a loop and it was like anything that was not port 80 dropped. And they had port 80 bound, and I don't remember why I didn't use it, but I didn't. So we'll just mooch existing comms. Anything you can get from C2 to target somehow, you can use, because you'll be able to see it, assuming you write your BPF filter properly. Like Buzz Lightyear, it's like not flying, it's falling with style. This is not comms as such, it's sniffing with style. If you're going to do like box to box to box to Pcap, logging happens, depending on how you're getting it there. We'll use SSH, that will cause some logging. But yeah, you don't actually need to go direct host to host. Bonus points if you get something else to do it, and then people are like, hey, so what is listening? And then you start to use this and like, hey, yeah, I'll just like implement some protocol where I'll keep like message numbers so I know to retransmit. And then you're like, I need something to tell me to retransmit. And you're like, well, maybe I don't need every retransmit. And then you realize you're re-implementing TCP. I have about 6 different iterations of TCP over DNS. And every time I'm like, I'm not re-implementing TCP. So tool I have out there, Pcap knock, and this is the one I wrote for that thing. And it just sniffs the wire and waits for something interesting. So you can either give it the word command, a command to run, and the word command, anywhere in a packet, as long as it can sense it on the wire. Or you can give it the word callback, an IP and a port, colon port or underscore port, and the word callback, and it'll call you back with a shell. It's nice and stackable. It's out there. You're welcome to use it. It runs standalone. It's cross-platform. I've put it on FreeBSD, OpenBSD, Solaris, Linux. Missing one somewhere. Probably not Windows so much. It's also I don't recommend it using it in an actual red team engagement, as it does no encryption, no authentication, there's no replay attack protection. So if you're going to use it, you probably need to add that kind of stuff in. And for the scenario, we'll say we have a log server compromised already. We've got root on it. So back to our transaction transfer box. We have some syslog server. We have root on it. We don't have direct comms to it because this is the only thing internet facing, and we're on the internet, and we would like to get a callback from syslog. We'd like somehow to get a shell in there. There's the Eskinema link again for this. So VIO0 is our local box. So we're .42 locally. And this is what we'll be using to trigger our implant. We can assume we have Pcap knock on the syslog box already. So this is what we'll be using to tell the implant to call us back. We'll use this as a login name. Obviously, it's not a valid login. Well, it might be, but probably not a valid login name. But what we'll do is make a syslog message that goes to the SSH server, and the SSH server will say, yeah, I'll call you back. That's 43 we're SSHing to. 42 is us. And we'll background SSH. All this is just to probably make it quicker and not require terminal input. And we'll just catch it with netcat. There we go. So we have it listening. Typical SSH-y stuff. There we go. We got a callback from 44. So the log server, 44. And this is the typical SSH, like, hey, permission denied. So I probably logged somewhere. Have a look. So what it looks like. Kinit is me. Kinit has just been SH with its file descriptors 0, 1, and 2. So standard in, standard out, standard error connected to the network. It has duped to a network connection over to it. Notice I got PS, which is the PS I was running, as a child process of Kinit, but a whole bunch more. That's because I couldn't really control how many times it was logged. I was talking about idempotency. This isn't. And I'm on his root. That's cool too. So that's where my code was living. So it's in systemd's, it's injected into systemd. Works pretty well. That's how I did it. Let's have a look at what it actually looks at on the wire. Notice injecting into libpcap, injecting into tcpdump did not work very well. I'm not sure why. I didn't have time to dig into that, unfortunately. So, got a syslog message. There we go. Syslog message looks like a syslog message, except it has our magic little string in there. So it calls us back. All of these, by the way, are on GitHub. And I'll link that as well on Twitter after the talk. The W there is just so that I can know tcpdump is finished. I learned the hard way to specify a packet capture count in tcpdump when doing these things when I have netcat, because Control-C does not kill tcpdump. Cool. So that's cool. So we have sort of two-way comms. We have inbound comms. We don't really have outbound comms. And if there's firewalling, the thing won't necessarily call us back. So we have this ability to read frames from the device and get them into user land. We can open a tap device. Linux's 10-tap thing. We can open a tap device and send frames from user land straight to the kernel. And iptables/netfilter will filter on tap 0 or whatever your tap device is, but it probably is not configured to do so in a lot of circumstances, unless a policy is dropped. It probably isn't. Likewise, we can take that tap device, read frames, get into user land, and we can inject with Pcap, which means we bypass a kernel nicely. Basically we've bypassed firewall nicely. So, firewall's cool. This also, by the way, I didn't write the code for this, but it makes a nifty VPN. If you take that tap device, put it remotely, have some sort of pre-existing comms between the two, and just use libpcap on the victim side to inject frames and sniff frames. There's a similar functionality in Cobalt Strike. I can't for the life of me remember the name of it. SSH's W option does something similar, just with extra steps. It also was like a first real offensive malicious Pcap project I made, other than Pcap knock, which was kind of simple. So basically what we got, network talks to Pcap, talks to our userland process, talks to tap 0 into the kernel, and then back. Tool called bypass FW, bypass firewall. It does exactly what we said. Again, to avoid copy pasting and finding it and having security researchers tweet at me with nasty grams. This will only work on OpenBSD right now. It's minor modifications. It'll work on Linux for your next engagement. The one caveat is BPF filters and ifconfig you can't necessarily just say, yeah, I'll just make up a MAC address and I'll DHCP an IP address and it works. Especially in virtual machines, in like a VirtualBox or VMware, the hypervisor knows what MAC address should be on that switch. And if you get it wrong, then it'll be like, no, someone's doing something funny. Or the other way happens and it's like your sniffing sees everything. It's like, I'm supposed to see that. So, take the network we've been on. We'll say FTP, for whatever reason, it isn't working. Probably because the last engagement, we were like, hey, we just did bad things with FTP. Please switch to something better. But, we still have the guy's creds. He didn't change it. Still gets SSH. And we want to FTP for whatever reason. So there's the source for this, ASCII cast again. This is what it'll look like. This is not the network this time. This is the on-target, architecture, for lack of a better word. Notional. This is not actually how it works if you look in kernel code. But, we're going to go get a frame onto the NIC. We'll have a BPF filter that says, yes, I would like that frame, get into our userland process, inject it via the tap device into the kernel. Likewise, the kernel will say, yeah, I want to send something out the tap device. We read from the tap device and go out. Tap device, by the way, which I probably should have mentioned earlier, most normal Ethernet devices or interfaces, you have kernel on one side and copper, fiber, Wi-Fi, whatever on the other side. Tap device, you have kernel on one side and software on the other side. So the kernel, as far as it knows, it's putting a frame on the network, but the driver is your code, and you can do whatever you want with it, like inject it onto the network again. Four. That's what it looks like in practice. So FTP did not work for us. We can still SSH in. We got his password. What on earth is going on? This is an OpenBSD box. I was like, do I use Linux or OpenBSD? And then I was like, do I compile it for Linux or OpenBSD? And that solved that. This is pretty stock OpenBSD firewall. It's a last match win thing. So we'll drop in on our interface and only allow in on port 22. So been told there's 5 minutes left, so we're going to go really quite quickly. Okay, so that explains why that didn't work. Put up our binary. Get on target. We're going to grab the MAC address of the existing one because this is a VM and we have to. You can either make the tap device before or after, or let the software make the tap device and set parameters, up to you. I find that easier to read anyways. Cool, it worked. We'll bypass it. And FTP works again. Maybe. There we go. So that nifty little way to bypass a firewall with minimal effort and minimal changes to the box. Got onto something and like 3 months later, there was big incident spun up. We need every config change you made to the box. I was like, I ran a program. So there is no config changes there once you stop the program running. All right, last thing in 3 minutes now. Steve Hanks some EDR. So this is a little Windows program. It was like, hey, this is all Unix stuff. Windows still has a very, very large footprint. TLDR, it watches for packets. If it sees a packet, it grabs IP port pairs, so the 4, 5 tuple, and asks the Windows kernel to please drop it. Program's called EDR Sniper, source, and I wrote a little wiper to test it with. So I just I Googled like best free AV, best free antivirus 2019, put it on target, or put it on a test VM, and put a wiper on the test VM. Please don't actually run that in real life. This is what this looks like. Notice inside the firewall, the Endus system. Cool. There we go. No Askinema, just a bunch of screenshots. So we have the wiper here, and we have EDR Sniper reporting what it's dropped here. And anything starting with a 7 will be the antivirus addresses. So it dropped some things, and, AV called out and was like, hey, is this okay? And it got a SYN, a SYNAC, and a reset. And then I'd drop some more things that probably shouldn't be gone, or I blew away some more things that probably shouldn't be gone, and AV was like, hey, is that cool? Anybody there? Yeah, it probably is all right. And then that happened. And at that point, thanks. This is all just normal Microsoft comms. The system is still up. Then I was like, hey, what happens if I do this? So that happened. So I've actually been asking over the past few days, hey, what happens if you don't have Carbon Black, Splunk, OS Query, whatnot? And the answer is, well, at a certain point, we just got to go knock on the door and tap on somebody's shoulder. So the flip side is if you drop all TCP, your user, your victim, will probably notice. I likely don't have time for a summary. So I knew I was going to be running out of time, as did my cat. Feel free to just look at the slides, the TLDR here. A couple ideas if anybody's looking for a quick, fun Pcap project. Any questions, which I'll take afterwards? Which I'm told I'll take afterwards. Twitter QR code there. All right, and thank you very much.